Hello teacher, today I'm going to my homework 9. Today we are going to dive into interesting and critical topic theory, a Turing machine that relation to decide the lines, recognize the bell, and closed properties. We will be looking at how this stable lines and closed under operations like union or complementation. We will look into all units. In this video I will walk you through each concepts step by steps, logical operation or and I will describe how we can use Turing machine understand these closure properties. Okay, let's draw it for the first question. Question saying that show that set of the disabled languages is closed under union. Okay, let's start from here. We have to start with input, and we are going two ways, L1 and L2. After that we got two options in here, yes or no. If we got also same options in here, yes or no. And after that if the answer was yes, we are going OR operator. If the answer was no, we are going AND operator. Okay, and after that if the answer was for L2, yes, we are going OR operator. If the answer was no, we are going AND operator. This is really gonna be accepted state. This is really gonna be rejected. Let me explain all of it. D1 decides L1, and after that D2 decides L2. Let's write all of it. I have to start from complement from here. Complement, swapping, Q accepted and Q rejected in Turing machine. And union, if I look at the union, D1 decides L1 and D2 decides L2. D1 decides L1 and D2 decides L2. I'm just thinking how can I move from here. Our first question, set of disabled languages is closed union. This means if we have two decidable lanes L1 and L2 is the union L. The answer will gonna be yes. We we will prove the using logical or operation. And step 1 input, we take a string running Turing machine L1 and L2 parallel. All operation, if either L1 or L2 accept the input, the machine will be accepted, and after that step 3, in the both machine reject the input. In the diagram, I imagine all the boxes left, L1 and L2. And after that, I have to write this equals in here, mention about the table M1 or M2 accepts and both rejects and halts. And after that, this one will gonna be condition also. This one will gonna be action. M accepts, M rejects, and this answer will gonna be yes. And after that, I am going to second question, show that the set of disabled languages is closed under complementation. Okay, I have to mention about input L1, L2, and OR and output operators. Let's start. Input. Okay, this is the code input. Given an input string to Turing machine L1, Turing machine M1 decides L1, Turing machine decides Turing machine M1 decides, sorry, Turing machine M1 decides L1, L2 will gonna be Turing machine M2 decides L2. I'm not gonna write again. After that, AND operator. If both M1 and M2 reject the string, we accept it. Okay, and after that, OR operator, the machine will gonna reject if either M1 or M2 accept the string. Okay, I'm not writing again. And output, the result will be yes if the string belongs to the complement, otherwise no, we are not accepting. Okay, drawing the diagram again. Input L1 boxes, L2 boxes here, yes, no, yes, no, or and rejected. from here. Yes, accepted. Okay. If the answer was no, we are going to or operator. If the answer was yes, we are going and operator. If the answer was no, we are going or operator. If the answer was yes, we are going and operator. After that, let's mention about the condition and action. Condition and action. Accepts. This one rejects. Rejects. Accepts. Halts and yes. Condition and action stuff, it's coming from here. This is looking good and enough. Okay, let's move on with the third question. Show that set of recognizable languages in closed under union. Okay, I have to delete all of it. Wait a second. What was the question? Question was show that the set of recognizable languages is closed under union. Okay. Let's start from the input, drawing the diagram. Okay. Input L1, L2. Yes or no? Yes or no? Yes or no? After that, or operator and operator. Okay, if the answer was yes, we are going or operator and yes. If the answer was no, we are going and operator. And after that, can't and we are saying no. After that, if the answer was yes, we are going or operator. If the answer was no, we are going and operator. What was our steps? Step 1, given to recognizable languages, L1 and L2, there exists Turing machine M1 and M2 that recognize them. After that, I have to mention about step 2. What was the step 2? We construct a new Turing machine M to recognize union L1 and L2. M runs M1 and L2 in parallel. We're gonna be on the parallel ways. Okay. After that, other question. What's saying other question? Determine whether the language of Turing machines that accepts nothing is recursively enumerable or not. Okay, let's draw a diagram from here. Is looking good. Yes, from here. Let's start from input. And we got to L1, L2. Okay. We got two ways. And after that, we are going to decision unclear. Okay. Decision unclear. Cannot decide This is important. I will give informations again. And after that we are going undecidable result. And after that rejection. Yeah, rejection. The problem is to determine whether this set is recursively enumerable. To recognize this language, we will need to verify for each Turing machine. Okay, verify for each Turing machine M that recognize it never accepts any input. Okay, we accept or not for every input. The halting problem is coming. Okay. Let's look at the condition and actions. Condition and actions. Machine accepts nothing. Machine accepts nothing, and action will gonna be cannot decide. Cannot decide. And after that, the condition halts and no. Okay. This is looking good. We can go with the fifth question. What's saying fifth question? Determine whether the complement of languages of all Turing machines that accept nothing is recursively enumerable. I can't say it. Enumerable or not. Okay. First of all, I have to draw the diagram. Okay, I have to draw the diagram. From here, I am starting with input and L1 and L2, and after that whole way is going decision unclear. The main important thing cannot decide. This part is important. Okay, after that undecidable result. Okay, after that rejection. Let me explain. This is opposite side of the problem in the question 4, and determining whether a Turing machine that accepts at least one input is still undecidable because it involves checking all possible inputs for acceptance, which is a non-trivial task created the halting problem. That's why the complement of is also not recursively enumerable. Okay, that's good.